We have a 300 series stainless steel plate. We have 2 stainless steel washers that are just off the shelf. And then we have a test magnet, which is a 1-inch diameter bar that is approximately 10,000 Gauss on the high poles.
No magnetism at all, completely non-magnetic. So here we have the little fragment that we just cut off the corner of the stainless steel plate. Again, the stainless steel plate completely non-magnetic. But if we look at this little fragment, we can see how magnetic that has become by work hardening. And the degree of magnetic susceptibility is directly related to the degree of work hardening. So the more something is worked, the more something is fatigued, the more work hardened it becomes and the more magnetic it becomes. When something gets worked extensively, in other words, a washer like this might fall into a grinder or it might fall into a mill, and it gets broken and it gets twisted, and a lot of working is happening here, and you'll find that fragment after it is completely worked extensively, it will now be highly magnetic. It's become very magnetic in comparison to the other washer. The other washer is very slightly magnetic. It's only really just holding on there, whereas this is holding on very tight.
This is a demonstration with the same stainless steel plate, and what I'm going to demonstrate here is the development of really small magnetic fragments that come off of moving parts in the process, like valves and blades and mixers and all sorts of moving parts in the food industry, which are stainless steel. So here we go. I'm going to grind off.
When we bring that magnet over and pick up those little fragments, we're getting these little tiny fragments of almost like dust. And those fragments are the kinds of fragments that are missed by metal detectors. So having adequate magnet protection is very, very critical to be able to collect those types of fragments that usually present as a black spot, but it's actually work hardened stainless steel.